All right, so in this video, we're going to review solving absolute value equations and inequalities. So first thing I've done here is written out kind of the steps that I would suggest that you follow when you're trying to solve any of these. Doesn't matter if it's an equation, a greater than or less than. The lessons kind of broke those three up, and there definitely are some differences, but these basic four steps we can keep the same. The first thing that's true is that no matter whether it's an equal sign, greater than, or less than sign, you have to get the absolute value by itself first. So that means get the bars alone. So move everything that's outside of the bars but on the same side of the equal sign away from it using opposite operations. Then we need to check, oops, moved my screen there. We need to check for special cases. This would be where there's no solution. This happens when you have bars less than a negative, or the other special case is when the way that the quiz will word it is all values are solutions. In Algebra 1, we called that infinitely many solutions. They mean the same thing. All values are solutions happens when you have bars set greater than a negative. Now, the equal signs, I should include here equal signs you can get no solution, so I should put an equals here as well because you cannot have an absolute value equal to a negative either. Remember that in the lesson it talked about how what absolute value is really a distance from zero. So that's why it's impossible for an absolute value to be negative in and of itself because it represents a distance and distance can't be negative. Then we're going to set up the two equations or inequalities. And I've got plenty of examples here so you can review how we set those up with an equal sign, with greater thans, and with less thans. Then you're just going to individually solve each piece. So when I look at A, first thing I want to do is get the bars alone, isolate the absolute value. In this case, what's in the bars is the only thing on the left side, so that's already done for me. So next I'm going to check for special cases. Do I have, since it's an equal sign, the bars equal to a negative number? I do not, so I don't have special cases, so move on to 3. Set up the two equations. Now, no matter which type it is, all 5 of these, when you set up the two equations or inequalities, you don't change what was inside the bars. So I'm going to write for both of the equations that I set up, I'm going to start with 1/2 x plus 5. And of course, in this case, my symbol in both is an equals. Now, one of them you're always going to keep just like the original except without the bars, so we'll keep that a 7. The other one on an equal sign, you're simply going to change the sign on the right. Again, do not touch what was in the bars. We're not changing these signs, just this guy. And in this case, this is going to be an and. It's always an and when it's an equals. And so then now we just solve each piece, step 4. So get rid of the added 5 by subtracting. That gives me 1/2 x equals 2. We get rid of a multiplied by 1/2 by either dividing by 1/2, which really is multiplication by the reciprocal of 2 over 1. So multiply both sides by 2, and that gives me x equals 4. Then my other piece, still going to subtract the 5. That gives me 1/2 x equals negative 12. Now when I multiply by 2 over 1, These, of course, cancel, and I get x equals negative 24. So my two solutions in this case are x equals 4 and x equals negative 24. All right, moving on to B, same steps. First, isolate the absolute value. In this case, that means this guy, this 2. That's outside the bars and it's on the same side as the bars. So it's multiplied. Opposite operation would be to divide. So I'm going to divide everything by 2. So that gives me now my bars alone on the left side. 18 divided by 2 gives me 9. Now I'm going to look for special cases. Do I have an absolute value? Do I have my bars less than or equal to a negative? No. Do I have bars greater than a negative? No, this is a positive value. So it's not a special case. So now I'm going to set up my two inequalities this time. Now, like I said in part A, you're never going to touch this part that was in the bars. Remember, we're not looking back to the original. We're looking at the isolated. So I'm going to start both of my inequalities with x minus 3 on their left side. The first one looks just like the original, so greater than 9. The second one, I am going to make it negative 9, just like I did on the equation, but because it's an inequality instead of an equal sign, I also flip this symbol. So change it to a less than. When your original has a greater than sign or a greater than or equal to, what goes in the middle is an or. So I did step 3. Step 4, solve each piece. This one's easy to solve. We just add 3 to both sides to get that x alone. So I have x is greater than 12, or when I add 3 to both sides here, x is less than negative 6. All right, C, step 1, isolate. So what's on the same side as these bars? This minus 5 is. So I undo subtraction with addition, add 5 to both sides. That gives me absolute value of 3x plus 1 is greater than or equal to negative 6. Now I'm going to check for special cases. So I'm looking, do I have my bars either less than or equal to a negative or greater than or equal to a negative? In this case, I do have it greater than or equal to a negative number. And so I know that a distance cannot be equal to a negative. It can be greater than a negative. So in this case, what this tells us is I know that everything that I put in here is going to end up to be a solution because this is saying distance bigger than negative 6. And distance, because the minimum distance is 0, is always going to be bigger than negative 6. So I don't even need to do steps 3 and 4 when I get a special case. I would just simply say all values are solutions. And then I'm done with that guy. All right, D, same steps, round and round, same exact things. So now I'm going to isolate. This plus 4 is what's keeping it from being alone, so subtract that 4 on both sides first. That gives me absolute value of 6x is less than or equal to 13. So now I do not have a negative on the right side, so that means I don't need to worry about that. So I can go ahead then to step 3, set up my two equations or inequalities. So just like on both A and B, that 6x that's in the bars is going to be on the left side in both of the inequalities I set up. First one looks just like the original, so less than or equal to 13. Because this is a less than, instead of the or that we do with greater thans, we do an and. And the way we set up the second one, same rules as the ors. you change the 13 to a negative, and you flip the symbol. So this was less than or equal to, I make it greater than or equal to. Now step 4, solve each piece. In this example, that just means dividing both sides by 6, so these cancel. So I've got x less than or equal to 13/6 and x greater than or equal to negative 13/6. Now, when it's an and, it means both things are true, and so this is a perfectly acceptable answer. But in the lesson and on your quiz, it's also going to want to make sure that you know that anytime you have an and like this, that it could be written as what I call an inequality sandwich. So you take the negative one, and x is sandwiched between that and the positive value, because below this guy and bigger than this guy means it's between those two values. So you can write this answer either way, but the quiz will want to make sure that you know both, that you know that these are the same, and that you can recognize the answer written as an inequality sandwich and as two separate pieces. All right, very last one. So in this case, I have 2 steps to isolate. So when I have multiplication to get rid of and subtraction, the subtraction goes first. So add 8 to undo the subtracted 8. That gives me 3 times the absolute value of x is less than, and then that's going to give me negative 4. Then step 1 still isn't done. It's not isolated. I need to divide both sides by 3. So absolute value of x is less than negative 4/3. Step 2, check for my special cases. So in this case, I do have a negative over here. So I look, if I have less than or equal to a negative, that tells me it's going to be no solution, because this is saying distance smaller than a negative, which is impossible. You can't have a distance being smaller than something that's negative. So this special case, again, when you reach a special case in step 2, that means you don't have to do step 3 or 4. You just write out whether it's no solution or whether all values are solutions. All right, that wraps up 1-4 for you.